Welcome back, boys and girls. We are once again working on the non-Euclidean top-down shooter. I hope you can see everything all right. Looks like you can. Let me just pull up the YouTube chat, which is a non-trivial operation. No one ever talks in the YouTube chat anyway, so... Content. I realize you can't see anything. Let me turn up the music a little. It was a little quiet on the last one. So you can have something entertaining to listen to, at least. There we go. Channel... is it under channel content? No. Channel content takes you to scheduling the stream. How do I get to doing the stream? It's not under dashboard, where you would expect it. Okay, okay. You go create on the other side of the heckin' screen. There we go. And then, for some reason, hitting go live takes you to the page where you manage your streams. I don't understand that. Whatever. Okay. That looks like that's everything set up. Pop that out into another window so I can read both chats. Welcome back, Missed One. Let me also start up the text-to-speech system. Forgot all about that one. Okay, so when we last left off, the thing didn't really work at all, I don't think. But I have made some advancements. Okay, that's a little too loud. Let me also turn it down for me. Let's see, can I get 45%? There we go. Okay. So we made some advancements off stream. This is, you know what? Let me turn that off because you haven't even seen the game working at all. Let me turn off the weird stuff for a second. That would be under
system initialized.
Yep, that would be under room draw visibility. We'll just dummy this out so it turns instantly. And then there we go. So this is the game. You can see moving between rooms is still not totally seamless because you see the player's aim position dances around. So we got to fix that, but it's pretty close to being seamless. We can walk around, and I think you can kind of see, the magic here. Like, so these, like, if you look here, these are the same rooms over and over again. Like, this isn't just an infinite loop of different rooms. These are actually the same rooms. And you can see now that I come back to the original Pentagon.
Yes, very nice.
Yep, this is the original room, the set of rooms we were looking at in the last stream.
It does look like a game now.
Yeah. And this one's a little bit more subtle. If you go through this tunnel made out of squares here, you can see... It's like, wait a second, that's impossible. Because we take 4 left turns, but we're in 2 different places. So hopefully that gives you an idea of what I'm trying to go for in this game. Oh, also where's the room... Where's the room that doubles back? Yeah. So here, this room is connected to itself. So, okay, it's not, you can see there's still a little bit of glitching. But you get the idea. You know, this is the same room twice. You can see there's my character. You can also see that the mouse, it sort of switches between, but it doesn't really. We need to fix that, but we'll fix that later. You get it. Like here, it's a room connected to itself. I go back. I see, you know, all the same stuff, but it's in a different orientation. Now, so the thing is, oh, I have to pull the game back up so you can see. You see, right now, it only really works because we're only showing... We have a depth of 1 in the depth first search. Ooh, also, okay, there were also some audio issues I noticed. Let me just... Yeah, I turned on this de-esser. but it seems to add a little bit of a glitchy effect, so we'll turn that off for now. Maybe I'll just get a little further away from my mic. Maybe that'll sound better. So in any case, the only reason this looks okay is because we're doing a depth of 1 when we search for, when we go through the graph of rooms. Now, if I go and I turn that back up, which will be, that'll be under draw. Draw. Ooh, actually I can, yeah. Room.draw. Oh, you can't see that. Okay. Oh, it didn't even work. Okay, never mind. PyCharm, you're supposed to be able to double press shift, and then it pops up this window where you can search for anything. But A, you can't see it when I do that, and B, it doesn't work. I'm getting increasingly tired of PyCharm, honestly. So yeah, this is what the game looks like if I don't have it set up that way. So this isn't really playable. Like, maybe in some places. I mean, like, right here it looks okay. But, you know, this would not... This'll give you a headache real quick. Although you can, at least, if I have it turned up, you can actually see... There you go, you can see in this room. There you go. So you can see the same, you know, proof that it's the same room. I also fixed the issue that... I think... Did I? Yeah, I fixed the issue that lets you slip out of the rooms at the corners. So let's turn that back down to 1. So, what I want to do is have it so that you can only see things that are... Like, you need to have line of sight to see. So this should actually work now. The problem is I've had a ton of trouble figuring out the line of sight algorithm. So this is going to be a little bit confusing. You can see there is a correct vision cone projecting out, like projecting through the room edges. The problem is, like, this is the only room where it works correctly, specifically because, well, it looks like it's working correctly. It's not. You can see it's going the wrong way. So this is the closest I've gotten to having it actually work, is where it's just going the wrong way. Which... And the thing is, every time I've been trying to... Like, I haven't really gone through it, is the thing. I haven't really focused. I've been using AI. And I guess this is just too complex for AI to handle still. I've tried Claude, I tried ChatGPT 01, their planning model. I haven't tried DeepSeek R1. That might be a cool thing to try. You know what? Okay, now that I think of it, let me... Okay, you probably won't see this either. Maybe I need to do a screen capture rather than a window capture so you can actually see the windows that pop up, but... Let me go into local history, show history, and then I can label this. I cannot label this, never mind. How do I label? Local history, put label, there we go. So put label, backwards, visibility, and I realize you can't see what I'm doing now. There we go. Okay. So now I can go back to the version I have now if I make changes. I will make changes, I need to fix it. And then I can go back and go back to this and try and feed it to the new DeepSeek R1. DeepSeek R1 is a planning model like... Not planning model, chain of thought model. I mean, all LLMs do chain of thought, but this is... We're talking about LLMs that are specifically trained to do a bunch of chain of thought. DeepSeek is... well, DeepSeek is a Chinese company. DeepSeek R1 is their response to OpenAI's O1, right? Yeah. You gotta love OpenAI's naming sense, naming things 40 and then 01 and then 03. They skipped 2 because someone has a copyright on the phrase 02, so they're calling the third one, the second one, 03. It's kind of like, was it Windows 11? Or Windows 10, rather. Because old programs for Windows check, because they had Windows 95 and Windows 98, and those were both very similar. And then Windows 2000, which came after 98, was totally different on the inside, so computers, a lot of programs need to tell, old programs from 1998 need to tell, hey, am I running on Windows 98 or am I running on Windows 2000? Or XP or ME, if you remember that. So they just, in order to say, am I Windows 98 or 95, they'll just check for Windows 9 and then not care about the end. But, no one knew that 20 years later they were going to try and come out with Windows 9. Well, they came out with Windows 8. No, they started with 7. Whatever. You don't care. Let me do the actual premise of the stream, huh? Okay, so what I need to do now is read through this code and try to understand it, because this is all AI generated. So I don't actually understand the code. That's the big problem with AI generation. So we need to lay off the AI for a while. As a matter of fact, once I get the game basically working, I am going to open up a tab with the game as it is now.
It sounds like Microsoft.
Yeah. Yeah, Microsoft sucks now. They used to be, I used to run defense for them a little bit, even though their business practices have always been really evil. But the whole embrace, extend, extinguish thing. But, yeah, now they're still evil. Well, they claim to be less evil. I don't know if it's true. I don't 100% trust them. But now their software sucks. It used to at least be good. I mean, good is very relative. A lot of people disagree that it's good. But he used to work. At least mostly work. Now you try to open, you go into Windows 11 and you open up the Explorer. You want to just go through your files on your computer, and there's huge visual glitches in Explorer. The advanced stuff, I have never on a Windows machine you're supposed to be able to use a smartphone, or even before smartphones, even feature phones, you are supposed to be able to access the internet through your phone from your PC with Bluetooth. You're supposed to be able to do that. I have never had that work on Windows. I think I got it to work for a second on one laptop running Windows 7, and then it broke, and I've never gotten it to work, ever. But on Linux, it just worked first try when I tried. I'm on KDE. You literally just turn on the feature on your phone, and you go connect, and it connects, and it works. You connect to the internet, it just works. Never worked on Windows, but at least the basics used to work. At least you could see the fucking files on your fucking computer. Now you can't even do that. And that's why I'm on Linux now. So, in any case, draw visibility. So draw visibility, this is a recursive function. I'm pretty sure it's recursive. It takes the Pygame screen, takes a transform from the parent call, the entry edge, the entry segment. This is a segment, this tells the child call how much of the edge that we're seeing through, how much of it we see. And this is the view direction, so that tells us, I wish I could draw. Maybe. I actually bought graph paper and colored pencils to A, to figure this out, and B, to demonstrate the algorithm, and then I don't have it set up so I can use them. But, maybe next time I have a thing that'll let my, like a bendy thing that'll hold my phone so I can hold it over the paper on my desk and draw, but That'll have to be for next time. So, yeah. If the depth is over the maximum depth, then we immediately return. Of course, the maximum depth is 1 for now, which is okay. We're just testing. Transform a point to screen space. So it takes P, which is a two-dimensional 2D vector. I would also like to go through this code and replace all these references to ND array with a custom vector class. I think that'll make things a little bit easier to read. But this is okay for now. You know, as a matter of fact, doing that would probably make it easier for the AI, now that I think of it. Shoot. I should have done that. Well, it's too late now. P homog. The other thing is it doesn't explain its terminology. I don't actually know... I understand the absolute basics of 2D vector math for game development specifically. But when it comes to like transform matrices, I don't really understand them. Which makes it very difficult to read this code because I don't know what... Like, I get that it takes the 2D vector, like, the center of a room is 0, 0, and if we imagine 5 pixels north of the center of the room, that would be this, I think. 5 pixels up from the center of the room, that's 0, 5. So what it's doing, what this code is doing, is saying, okay, 0, 5, add a 1. And I guess that makes the vector homologous, but I don't understand what that means. I get what the reason it's doing that is so that it can multiply it by a 3D vector, which is the transform. I just don't understand the implication. Like, I understand what it's doing, I just don't understand the implications of it, I guess. I'm not familiar. I don't grok it. I understand it. I can explain it, but I don't feel it. I don't grok it. I can't manipulate it in my head. It's not natural for me. It's also odd that it's taking a vector and returning a tuple. Wait, what? Why? Okay. AI weirdness already. This is the six-fingered hand of the code world. Even though they fixed the six-fingered hand thing years ago now. Root room visibility. So the other thing I really don't like is that it completely separated the two cases. Like, we handle the root room, the room that the player is in, completely differently from rooms that the player is not in, he can just see into. Nonetheless, for the player, okay, we find the player. So this is just going through next, takes the next value from an iterator. This creates an iterator. So this is kind of a loop wrapped into an object. Specifically, this is a generator. So when we call next on this generator, it runs this loop once and returns the result, or if the loop exits, it returns none. And the loop is E for E in self.entities if E is a player. So it goes through its own entity list and picks out the player, returns it, puts it in player. If we can't find the player, oops, everything's fucked. Like, this is never supposed to happen, so we return. I would have liked if this raised an error, actually, but the AI chose to just return. Transform point. Oh, okay, I get why transform point is like that, because it's transforming from... We use NumPy arrays for vectors in the logic, but Pygame, in order to draw to the screen, it wants a tuple of two floats. Let me also do the trick where I watch my own stream on mute. Here it is. I gotta grift a little bit here. There we go. And then for each connected edge, yeah. So in the root room, because the rooms are convex, they cannot, like... Because the rooms are... I wish it was easy. I need to figure out a way to make it easy to draw stuff. That's a note to self for the future. If you imagine, I'll draw it with my cursor, and you'll have to imagine it, like, or you can just look at the game. Like, I hope it's immediately obvious to everyone how wait, why can't you see the game now? Okay, there we go. I hope it's immediately obvious to everyone that there can be nothing in these rooms, well, things in the rooms. There's no way a room can cast a shadow on itself, right? Because it's a convex polygon. It cannot have, like, if we had a section taken out here, that would no longer be a convex polygon. That would be invalid. So in addition to breaking the logic that detects whether or not you're in the polygon, that would also mean that the room can cast a shadow on itself. If this was hollowed out and we were standing here, we couldn't see here. So that's not allowed. So we know if you are in a room, you can see the whole room always because they're convex. So that makes things really simple for the root room case. The problem is when we're looking through a portal into another room, which we always are, because that's all there is in this game is portals. So you can kind of see, because it kind of looks like it works in this specific case because the room is looking into itself. If you imagine that we were in this room, this describes the cone. It's not a comb, it's a two-dimensional frustum. This describes what we can see, right? Like, you can't see this point here because this wall is in the way. You can't see it. And if we go here, now you can't see this because this wall is in the way. But you can see, if you go right up to the room, now you can see everything. Also, the nice thing is I had an approximation that actually worked. I had it working for a second, but it broke down when you got close to the edge. So you would see correctly, you would see only the parts of the room that are under the cone here, under the frustum. But then you would get close, and then the half of it would go black, and you couldn't see. So I had to throw that out. It was fundamentally wrong anyway. But yeah, I got close, and then I had to throw it all out. So you can also see these yellow dots represent the intersection between the lines that make up the sides of the frustum and another portal, another edge, another connected edge. That's the terminology I'm trying to use, because they're not supposed to be portals. They're supposed to be just connected space, but you can see it draws the dot at the intersection correctly. It's just that it's flipped wrong, and the cone is shining into the origin room rather than out of it. So I don't know, I don't understand why that's happening, but we're gonna figure it out, and we're gonna fix it. We're really close. It almost works. This is the thing that, like, it's a really good sign when something doesn't work, but it always doesn't work in the same way. Because earlier I was dealing with sometimes the lines would go the wrong way, and sometimes the lines would cross over themselves for no apparent reason. So when things are failing in the exact, like right now, it's just the opposite of what it's supposed to be, right? So now we just need to go in and find where we have to flip it back, instead of being just confused because it's doing different things in different situations. So it's broken in a really good way. It's almost right. It's just rotated by 180 degrees. So back to reading the code. For each connected edge for the edge index and the edge in enumerate, enumerate goes over an iterator. In this case, the iterator is constructed out of a list. The list of edges of the... wait a second. What are the... Yeah, okay, the edges are the edge object. So we have the edge object itself, and then the index of the edge object. So we go 0, 1, 2, 3, up to 8, well, 7 if it's an octagon. You get the idea. So if this is a connected edge, if it's not a connected edge, then we don't want anything to do with it. We just draw the wall. But if it is, okay, that's a portal. We need to look through it. So we get the start and the end. Why? What is self get edge vertices? Shouldn't that be easy? Oh, okay. Yeah, okay. So it's just finding it goes into its own list of vertices. I should make this simpler. But it goes into its own list of vertices. The vertices are just the points, the corners of the shape. It finds the corners, the vertices, and then it takes the first corner that is part of the edge and the second corner that is part of the edge. And then those are the two corners that make up the line. How do I go back? Why is this broken now? Oh my god. No, that's definitely wrong. Crud. Why? So it used to be that you could hold... there we go. Okay, it's Control-Alt-Left. On Windows, it's Windows-Alt-Left. But I guess on Linux, I don't know why it took me... I've been using Linux for 2 years. Okay, not 2 years, like a year. Okay. We have the start and the end of the line that we care about. Transform everything to target room space first. See, this is where the error must be, right? Right? What if we don't invert the transform? Just throwing crap at the wall here. Yeah, see, if we don't... Oh my god, if we don't invert the transform, everything's fucked. That's not right. Yeah, this is that error I was having earlier, where... Okay, can I find... Yeah. They cross over each other. I don't... Why is that happening? What really drives me crazy about this is you can see it's shining into the room correctly now. Basically, the line is 90 degrees off instead of 180 degrees off. Except sometimes the freaking line is still 180 degrees off, but sometimes it's 90 degrees off. I don't understand. I don't understand. I wish I had the geometric knowledge. And also, sometimes you can see it's not 45 degrees off, it's some other number of degrees off. It must... I don't know. So, okay, so it looks like the invert is correct, and we use that same invert like in the code that moves the player between rooms, so I'm pretty sure this is right. Transformed start. And this is homologizing the vectors so that it can be multiplied by the 3x3 transform. So we take the transform. The transform represents the transform represents how a point has to move to represent a point. Like, take a point from the root room and transform it so that you get the same point in the target room, because they're rotated relative to each other. Especially in cases where, say, a room is looking into itself, you need to rotate those points 180 degrees in order for things to match up. So that's why we have this transform. So we take the start of the edge and the end of the edge, And and the player's position, and we transform them into... Okay. Does that make sense? Maybe let's just... I think it does, but let me try it. Did that fix it? Oh my god, that fixed it. That was it. Okay, let me just make sure this actually fixed it. Holy shit, it fixed it. Never mind! No sir, did not fix it! Fuck! Okay. So we're closer. We're we're definitely closer. But, we're not quite there. No, sir, we are not quite there. That's not right. That's definitely not right. Okay. No, that's not right. Okay, maybe we didn't... Why... Specifically in the case of a square, this is exactly correct. And that's a clue. I don't know how to interpret it, but that's a clue. Do you see? Do you see what I see? No, this isn't correct. This isn't correct. No, this is totally wrong. No, I'm totally... No. There's multiple problems here. There's multiple things wrong with this. That's what's happening. Okay, I hope I don't sound too crazy. This is how I get when I program. So you can see these red lines represent... The red lines were being covered up by the green before. That's why you couldn't see them. These red lines represent the angle, the line from the player to the edges of the portal into the next room. Right? So... This should be, it should be that the green line is just the extension of the red line into the next room, right? Because that represents what you can see in the next room. And in the specific case of a room that looks into itself, it works. Like, why does it only work for a room that looks into itself? That's a clue. That's a clue. Because a room that looks into itself is always exactly 180 degrees. It's exactly half a rotation. It's exactly 1 pi radians. It's exactly half a rotation off. It's exactly half a rotation off. That's what's happening. You see that? That's what's happening. Right? That's 180 degrees right there. Am I crazy? Nah, wait. No, I am crazy. That's not 180. That's not 180 degrees. Never mind. Wait. Okay, hold on. No. Okay, if it was always 180 degrees, this would always... Well, yeah, if it was 180 degrees, we would have the problem we had earlier. So that's not the problem. What is the problem? Why does it work? Why does it work perfectly only in the case of a room that looks into itself? That is a clue. But what does it mean? What the hell does that mean? Okay. Let's keep looking around. In the case of a square, I don't know why I thought that it worked right. For a while, I thought that it worked right because it's kind of like it's doing exactly the opposite. It's doing exactly the opposite of what it's supposed to. Yeah, because I should see less of this room, right? I should see this. I'm butted up against this wall, and I can see this side of the room, but not this side of the room. That's the opposite of correct. So something else is wrong. So yeah, the green line needs to be an extension of the red line. And in the case, you know, that's interesting. Is it? Bam, 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 bam. Yeah. It's something to do with the rotation. It's something to do with the rotation between rooms, because you can see that the effect gets worse. The problem gets worse the fewer sides the room has. Did you notice that? And why would that be? Because a room that has more sides, you on average need to rotate less. That's the problem. Ooh, okay. What's happening here? Man, it's so close to being right. Is this a clue? Is that correct? You know what? Do you see this octagon here? Wait, that's not an octagon. I think that's a heptagon? 1, 2, 3, 4, 5, 6. It's a hexagon. Wow. It's a hexagon. Yeah, in the case of this hexagon, look at it. It's perfectly correct. It's kind of hard to see because this one's room, or maybe this one's is drawn over it. Wait, what's happening? What cone is this? Whose cone is this? Oh no. But you can see in this hexagon, it's correct. This is exactly the behavior we want. You can see... No, wait, it's not? It is. The green line... I have to move away for you to be able to see it. You can see the green line is the extension of the red line. In this one room. In this one room, it's correct. None of the others. Why? Not just in this one room, in this one pair of rooms, because if I go here, it's wrong again. Is it right here? Yeah. So this one connection works completely, utterly perfectly. Isn't that something? So what I bet is happening, I'm not sure how I would prove this. These are the only two rooms in the test level that are not rotated relative to each other. I think that's the case. I don't know that for certain, but I think that's what's happening. So it must be a problem in the application of the transform. The problem with that is the position part of the way we're applying the transform is correct. You can see in all cases, the end of the red line and the beginning of the green line, they always line up. Always, always, always. Right? Yeah. It's just their direction doesn't line up. So it is specifically the rotation that is wrong. And I do believe... Wait. Okay. Wait, okay, no, I gotta think. Transformed ray directions. Okay, we are transforming the rays. And then we negate them. What if we don't negate them? I think this will just break everything, but let me check. Yeah, that definitely ain't right. No, sir. Yeah. Okay, let me experiment here. Yeah, the rays are going the right... Yeah, the rays are exactly 180 degrees off, so yes. This is correct. This is 100% totally correct here. These two lines, you know, real patriots confirm these two lines are good. It must be here. The problem must be here. Okay. So why is the problem here? Oh! Unless it's not. Because the problem could also be here. Okay. Just, I'm throwing crap at the wall here again, but what if we don't invert the player transform? No, that is definitely not correct. That is very much not correct. Okay. Okay. We're throwing crap at the wall again. Shotgun debugging. No, okay, that's silly. Wait. Now it's working. It's working in that specific case. Did the room that worked before? Now the room that worked before is not working. Wait. No, this is the room that worked before. Yeah, now the room that worked before is weird. So... is this room correct? This room is correct. No, it's not. No, it's not. No, it's not. Because they aren't rotating enough. You see that? Like, I should be able to see... this is basically right. But if I go over here... not quite. I'm a poet and I don't know it. But this is completely right. But if we go here, again, it feels like there's multiple problems. Multiple problems. And then there's also this. What the hell could that be? I just don't have the geometry background to figure this out. I wish I had a larger audience so there would be like a mathematician in chat who's like, yeah, dumbass, you gotta prognosticate the frobulator before you apply the inverse transform. Of course, everyone knows that. And then I would just do it and it would just work. But no. So I wonder if I've actually fixed something by doing this, or doing this has just broken it in a way that cancels out with something else. You know what I'm saying? Let me make a note of that. transforming the player's position has to be correct. It has to be... I wonder if I can just go on Mathematics Stack Exchange. I'll do that after this stream. I do have somewhere I want to go. This will be a little bit shorter one. I think we got another 45 minutes. Man, I just don't know. This has to be right. Not transforming, we have, okay, clue. Not transforming the player's position. Replacing this with just player.pause. Causes the rays to project into the target room as expected, and in cases where the... I need to check. It could also be that they're not lined up, but they're exactly some degrees off from each other. But let's just say for now, in cases where the connected rooms are not rotated relative to each other, up points in 0, 0, 0, 1, minus 0, 0. Well, yeah. Points up. Points. It's true. Points straight up on the screen in both. Well, in the exact same direction on both. That's how I'll test my theory, actually. I'll make it draw a line. Everything is exactly correct in rooms where they are rotated relative to each other. This causes they project into the room correctly, but they are rotated relative to but the green line appears at an angle to the red line, and the speed at which the angle changes seems to depend on the number of sides the room has. The target room has. The speed at which that angle changes as the player's angles to the vertices of the edge he's looking through seems to depend on the number of sides the target room has. Okay. That's our clue. That's one clue, at least. And if we go back to the broken code, we see this. So we don't actually know that the problem is here. The problem is somewhere. The problem is somewhere. What a enlightening statement. There is definitely, yeah, there sure is an issue somewhere. The question is where. The question is where. I need to get up and take a break. Let's see. Is there a way I can put something on? No, I don't need to get up and take a break. Never mind. Let me just sip my water. Okay, let's try going back to the AI. I may regret this. What are we thinking? I would also like to take some time to maybe... Okay, well the thing is... No. Because we're not even trying this. This never runs. Because we have depth set to 1. So this never even runs. Wait, what? Yes, it does. Yes, it does run. Why was I assuming that? That's not correct. This does run. This is the only That was an interesting brain fart. Why did I think that? This always runs. Because this is the code that actually draws the things we're seeing. What the hell? Okay, so if the call is for some reason invalid, we return immediately. Again, I would have liked an error message. Get the entry edge vertices. We get the start and end of the edge that we're looking through. The player is looking through. Target edge, edge.target. Yeah, that's correct. That's correct. Calculate visible segment points. So what this is doing, this is calculating... What is this calculating? Yeah. So this takes... That's interesting. EdgeVec is end minus start. So this is a line from the start to the end. Right? Or is it a line from the end to the start? I don't know. But all this is doing is entry segment is two numbers saying, okay, from the start and from the end of the edge, how much of that edge is already shadowed. And this will always be the entire, these factors will always be 0. Because we're only doing depth 1. I'm sure that that behavior is broken too, but for the purposes of what we're doing today, these are always 0. So this multiplication is always 0. So viz start is always exactly equal to start. Viz end is always exactly equal to start. What? Oh, no. It just didn't do it the way I thought it did, so this is correct. I'm not super into how it did that. Also... Yeah, so viz end is always equal to end minus start plus start. So it's equal to end, which I'm not super into. What? Just for the sake of my sanity, viz start equals start, not starret, start. Viz end equals end. Does that change anything? That changes absolutely, positively nothing.
One thing you could ponder is why the cone's length is sometimes greatly shrinking as you approach the room boundary. Not intentional, is it?
Yeah, I did notice that as well. I don't know what's up with that. That... Here, let's undo what I just did, because it's not necessary, it doesn't change anything. Let's remove this, so I can show you what I'm thinking. Player.pause. So I believe that is actually correct, because what is happening... The reason the cone is getting shorter is because it's a little odd that it's always drawing the cone exactly half up the green rays. That is odd. Well, they're not rays, they're lines. They would be rays if they didn't end. But the reason the cone is getting shorter is because the angle between the sides is getting larger. So that's actually... Why is it like that? Okay, hold on. When we draw the cone...
I see.
When do we draw the cone? When do we draw the cone? When do we draw the cone? What? When do we draw the cone? Try to localize show frustum edges. Oh, no. Okay, no, okay. Yeah. These are the red lines, which I could have figured out because...
There's no problem then.
Yes, I think. I would like to double check. What is this? Width. What? Oh, that's just the transparency. That's fine. This is just the transparency factor. I'm wondering why it draws the cone. I don't think so, but you may have put me onto something. You notice how it draws the cone only halfway up the green lines? That's odd, you know? But you can see that the green lines are always the same size, it's just the angle between them. But nonetheless... What? Why is it only... why is it only drawing halfway up the lines? B, you'll notice if I go like here... Okay, that's just because the angles are screwed up. That won't happen once we fix the other bug. I was saying, hey, why, this would cut off half of this room, but that's just because we haven't fixed the other bug. In the case where it's actually correct, that doesn't it does happen. It does happen. Okay, but there's an easy fix for that. I just have to turn these into actual rays so they go on forever, and then I clip them to the size of the screen instead of arbitrarily clipping them by, I think it's like twice the diameter of the room. That's fine. That is a problem, but it's not the problem we're looking into right now. In fact, we can probably fix that just by doing this. Yeah. Well, even so, that's still not right. But, yeah. Yeah, so we would, like, if we do... That slows down the game a whole lot. Yeah, so if I make it ridiculously large... Well, the larger I make it... Will this be a problem when I actually release the game? Possibly. Well, we'll burn that bridge when we come to it. But, just making the lines longer helps. So we'll just have to, like, make them infinitely long and then clip them to the size of the screen. That's fine. That's not the problem we're thinking about right now. Also, the stuff on my other screen keeps flinching and it's distracting me. I gotta minimize the stuff. Yeah, oddly enough, streaming... That's not that bad. It puts some load on my computer. Believe it or not. Especially because I'm streaming to 2 platforms, so I probably actually do have twice the CPU load of a normal streamer. That's fine. Frustum points. So the shape of the... That is interesting. Why? 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 Transform is the camera transform. That's fine. What? Okay, now I'm really confused. Oh. Oh? Okay. So now the rays actually follow, like, show the edges of the frustum. You notice how it's using the same... This code is odd. Yeah, there's also some shenanigans happening here. You know what? The reason we're seeing this issue, so if the game was actually running the visibility code that I want it to run, this part of the room, the part of the room that, like in all cases, the part of the room that isn't green would not be drawn. It would, like, everything that isn't under the green shape would be black. So, what's curious to me... See, the thing is that we aren't actually drawing the cone from the player object's position. We're drawing the cone... Is that a clue? Well, it must not be, because we're doing it in this case. The fucked up part... We're exactly 180 degrees off. What the fuck is this song? Skip that. We're exactly 180 degrees off again. No. Yeah? No. Yeah. What? We are. No. What? You notice how it's perfect if I'm in the exact center of the room. I know for a fact that these two rooms are aligned. You know, one thing I could do is add some other information to this debug view so that I can see how the rooms are rotated to each other. That might give me some clues. It is exactly, perfectly, utterly correct. Except in the case where we approach the edge. That's another issue we'll have to solve later. Unless it isn't. Unless it isn't. In the case of a room looking at itself. If we don't transform the player's position. And also... Wait, is this room okay? Hold on, let me flip around. So it's easier to see. And also this particular room boundary, the boundary, those are rooms 1 and 2. That's an interesting coincidence. This boundary here is also exactly correct. Let me add something to the debug visualization. The other debug visualization. Let's see. Let's find the show room numbers. If drawn room numbers. Let's also how do we homologize? Is that the right word? Homologize? I don't even know. Homogenize, not homologize. Why did I think it was homologize? Going insane. What does homologize even mean? It means to make a homology, which a homology is like an analogy, but you say is instead of is like, I'm pretty sure. Okay, that's not relevant to what we're doing right now. Oops. This is really sloppy, messy code, but I'll clean it up later. Also, I also accidentally deleted... I guess I actually want the y-axis, huh? It doesn't actually matter, but it matters to me. It'd be kind of nice if it was a line, but... Or not an arrow instead of just a line, but... okay, you know, okay. I actually want to... Well, that's fine. Equals... np dot draw dot line. Hold on. Surely. It's really cool how it does that. Okay, there we go. Okay, we use it there. That's correct. That's correct. We don't use the stacked transform anywhere else, right? Okay, never mind. I was worried that we were using a transform rather than, you know, edge.transform. We aren't, right? We aren't, right? We aren't. Okay, cool. Good. That's correct. You know, it's fucked up how we always have to invert the transform before we use it. I wonder if I should invert the transform first. Well, invert the transform when we create the edge, rather. Transform point. I kind of wish it clarified that this was transform point for drawing. But that's not what's important right now. This code is a horrific mess. But I would like to get it working before I clean it up. We need to. We need to. Okay, that's fine. Whatever, let it be messy. It's fine, it's fine. NP draw, not NP, what? We're, Pygame drawline. Criminy. Pygame drawline. And that's surface color start pause in pause. So surface is surface. No? Room surface. Room surface. Color. We can have it just be, let's have it be yellow. Yellow is green and blue. 0, 255, 255. Just for crazy cuz, we'll have it be yellow. And then we need the start and end, right? Right. So center transformed. 0, 1 transformed. We'll have it be a little bit thick. There we go. And then, why are you screaming? Right. Yay. I need to tuple. This is also messy, but it's fine. I think this is correct. Is that what you wanted? I hope so. Is that what you want? No, that is not what it wanted. Right. Okay. Okay, well now I... Oh no, you have to actually turn it on. Right, the line is there, but it's really tiny. Okay, so let's make it a little larger. Like 100? There we go. Okay, that's not yellow, but that's fine. So you see these, you can see the cyan lines are pointing right at each other. So these guys are, obviously, because it's the same room, exactly 180 degrees off. These guys are 0 degrees off, and you can see that the angle of the rays is exact, like... It has this property where the rays are exactly off. You know, you see that? Like, it's exactly wrong. Like, this guy should be straight up and down, and this guy should be at an angle. It's exactly the opposite of correct in terms of what? It's exactly the opposite of correct in terms of... We know how to transform rotations because the, I wonder if we do. I wonder if we do. And then... Yeah, in this room that... right, I have to flip so you can see it. In this room that I thought was exactly correct... This room, yeah. You can see... I was right that it wasn't 100% correct. It's mostly correct, and it's mostly correct because you can see these are almost at 180 degrees to each other. So there is some way in which our transformation is exactly 180 degrees off. I don't know what that is, and I am getting tired. I think we've made good progress. We know... Before, we didn't know what the problem was, right? Now we know. We know exactly what the problem is. We don't know how to solve it, but we know exactly what the problem is that our transform is rotating when we pass in the angle for the... We need to calculate the angle... What angle do we need to calculate? What angle are we calculating? We are calculating the angle... We're calculating half of the angle between these two red lines. We are calculating... In fact, we're not. No, we're not. We are calculating the angle from the line from the player's position to the center of the target edge to the left and right edges of the edge. The left and right, the first and last vertices of the edge. That's the angle we're calculating. That angle is exactly no. In cases where the rooms are exactly at 180 degrees to each other, the angle is exactly correct. It is being transformed exactly correctly. In cases where the room... Let's find a room where they're exactly aligned. Can we find a room like that? This one's close. Yeah, in rooms where they're exactly aligned, we get that exactly wrong behavior, right? We get exactly the opposite. So... So somewhere when we do the transform of that angle, we are accidentally rotating it by 180 degrees. No, we're not. We're not rotating it by 180 degrees. We're accidentally inverting the vector. Yes? We are flipping the x and y of the vector. Yes, that's what we're doing. These two rooms are aligned. This is exactly what it looks like. Because this line is 1, 1. We are from 0, 0. I mean, it's along the 1, 1 line. It's going one step along the x-axis, and one step, one, you know, an identical size step along the x-axis. In the case where that's the case, you see it's exactly right. But then, like, we can get it to be 90 degrees here. And why is it 90 degrees? What is happening when it's 90 degrees? This is 0, 1. This is aligned to the y-axis. What's happening here is that we're flipping x and y. Like, our x and y values are correct. They're exactly correct, but only in the case where they're aligned. Because if they're not aligned, it's perfect. If they're exactly not aligned, it's perfect. Why? And what the fuck is happening here? See, these are at about 45 degrees to each other. 20 and 19 are. And what hurts the most about this is I know that anyone who actually understands geometry could look at this and be like, yeah, dumbass, you gotta do the thing when you invert. You gotta do the thing when you imply the transform. But I went to an American public school, so I don't understand geometry. Okay. So we actually don't know what the problem is, but we do have a precise... No, we don't even have that, do we? We have a really well-described symptom of the problem. We know that it's exactly correct, the rotation is exactly correct when the coordinate systems of the two rooms are at exactly inverse. What happens? I said the word inverse. Didn't we already try? This isn't right. But what does this do? That preserves this case. Why? What is so special about the case where why are we transforming the player's position into... Wait. Surely. This better not be right. Okay, it's not. Good. Wait. Do you notice how they cross over at exactly... God, I just wish I understood geometry. Ah. Okay, well, I'm exhausted, so we're gonna call it here. I was really hoping to get everybody a win on stream here, but it's not meant to be. So I'm going to do some more talking to AI about this now that we have a better description of our primary symptom. I can at least take that to the AI, and maybe that will cue it to give me the information I need to fix it. But until then, I will see you all next time. Let's look for someone to raid. Let me
Sounds
open up.
like you are almost there.
Yeah, we're getting closer. I mean, this is how programming is. This is how it is at work, too. Usually at work, things are easier. But, yeah, this is just how programming is. You screw with it, and you screw with it, and you find symptoms, and you try to...
Don't flip X and Y somewhere.
Yeah, that's it. But the thing is, that's not quite it. That's not quite it, because it's only in that one case where they're... Man. It's only in that one case where they're off by 180 degrees. No, when they're off by 0 degrees, that it's inverting it, that it's flipping X and Y. Because if they're like at 45 or 90 degrees to each other, it does something else. I don't know. I gotta figure it out. Okay, who can we raid? Who can we raid? Who can we raid? We can raid... Let's do Suspicious Wizard again. He's doing, he's playing XCOM files. So we will send you, into his stream in just a second here. Raid Suspicious Wizard. Have fun with Mr. Wizard. I will see you all next Monday. Goodbye.